Welcome to the episode 2 on limits and continuity in mathematics, EAPCET mathematics first year syllabus. So, we are a continuation of the previous episode. So, let us start the 22nd question. The value of limit extends to 0, square root of 1/2 of 1 minus cos 2x whole by x is the JEE question, that means meant for IIT admissions. So, simple question. So, this is the 22nd question. Limit extends to 0, square root of 1/2 of 1 minus cos 2x. 1 minus cos 2x is 2 sin squared x. So, 1/2 of 2 sin squared x is root of sin squared x, and square root of sin squared x is not sin x. Square root of sin squared x is mod sin x. Square root of x square is not x. Square root of x square is mod x. So, square root of sin squared x is mod sin x. So, numerator is mod sin x by x. Well, you clearly know that this limit does not exist, because when x tends to 0 through positive values, one-sided limits, we are considering one-sided limits. That means, when x tends to 0 from right, sin x is positive in 0 pi by 2. So, mod sin x is same as sin x, which is 1. When x tends to 0 through negative values, in the interval minus pi by 2 0, open interval minus pi by 2 0, well, mod sin x is negative. So, mod sin x is minus sin x by x, which is equal to minus 1. So, for this limit, the two one-sided limits are different. The right limit is plus 1 and the left limit is minus 1. Therefore, the function cannot have a limit at x equal to 0. Therefore, the limit does not exist. So, the answer is none of these. Then 23. Limit extends to, this is also a question appeared in the 1999 JEE. Limit extends to 0, x tan 2x minus 2x tan x by 1 minus cos 2x whole square. So, we apply simple trigonometry. Tan 2x is 2 tan x by 1 minus tan squared x. So, when you take when you expand this, when you replace the tan 2x by 2 tan x by 1 minus tan squared x, I can take out 2x tan x common into 1 by 1 minus tan squared x minus 1 by 1 minus cos 2x whole square. Follow? I replace the tan 2x by 2 tan x by 1 minus tan squared x, and I have taken out 2x tan x common from the two terms in the numerator. So, that will be 2x tan x multiplied by 1 minus tan squared x minus 1 by denominator same 1 minus cos 2x whole square. When you simplify 1 by 1 minus tan squared x minus 1, when you take LCM, it is 1 minus of 1 minus tan squared x, which is tan squared x. So, therefore, this is limit extends to 0, 2x tan cubed x by 1 minus cos 2x whole square. No harm even if you leave out 1 by 1 minus tan squared x. Even if you write 1 by 1 minus tan squared x, the limit of the second factor will be equal to 1 as x tends to 0, and therefore, this can be left out. Now, divide numerator and denominator by x power 4, because you get tan cubed x by x cube, which is tan x by x whole cube, and the limit of tan x by x whole cube as x tends to 0 is 1. And therefore, this is limit extends to 0. 2 times tan x by x whole cube by 1 minus cos 2x by x square whole square. Follow? ఏం చేశాను నేను న్యూమరేటర్ని డినామినేటర్ని కూడా x పవర్ 4తో డివైడ్ చేశాను. x ఒకటి న్యూమరేటర్లో ఉంది కాబట్టి అది క్యాన్సిల్ అయిపోయి x క్యూబ్డ్ ఇంకొస్తుంది డినామినేటర్లో. tan cubed x by x cubed is tan x by x whole cube. In denominator also you are dividing by same quantity x power 4, which is x square whole square. So, this will become 1 minus cos 2x by x square whole square. And the limit of tan x by x is 1. So, this is 2. 1 minus cos 2x by x square. 1 minus cos 2x is 2 sin square x. 2 sin square x by x square. Sin square x by x square limit is 1. So, 2 square is 4. And therefore, the final limit is 1 by 2. And therefore, third option is the correct choice. Okay, next. 24. The screening paper of 2001, limit extends to 0. Sin pi cos squared x by x square equals. కొన్ని మనం చాలా జాగ్రత్తగా గమనిస్తే ఈజీగా ఉంటాయి. రెండు యాంగిల్స్ సప్లిమెంటరీ యాంగిల్స్ అయితే వాటి సైన్ రేషియోస్ ఒకటే. Sin theta is same as sin 180 degrees minus theta or sin pi minus theta. So when two angles make up pi radians or 180 degrees, their sin ratios are equal. For example, sin 30 degrees is same as sin 150 degrees. Sin 60 degrees same as sin 120 degrees. Pi cos square x is there in the numerator. Pi cos square x plus pi sin squared x is pi. And therefore, sin pi cos squared x is same as sin pi sin squared x by x square. I write this as pi sin squared x into pi sin squared x by x square. Follow? I multiplied by pi sin squared x and also divided by pi sin squared x. Sin pi sin squared x is same as sin pi cos squared x. You follow this? And this is in the form sin theta by theta. As theta tends to 0, limit x tends to 0. When you put pi sin squared x theta, when x tends to 0, theta also tends to 0, limit of a composite function. So this limit will be equal to 1. And sin x by x has a limit 1. So this is equal to pi. So there is second option. 25. Limit 1 minus x into tan pi x by 2 as x tends to 1. Joint entrance of 1984. Limit 1 minus x into tan pi x by 2 as x tends to 1. Put 1 minus x equal to theta. Then as x tends to 1, theta tends to 0. Follow? The limit of theta as x tends to 1 is 0. Using the result on the limit of composite functions, the limit becomes limit theta tends to 0. 1 minus x is theta. Theta tan pi x by 2. Pi by 2 into x is 1 minus theta. Follow? X is 1 minus theta. When 1 minus x is theta, x is 1 minus theta. Or this is limit theta tends to 0. Theta tan pi by 2 minus pi theta by 2. Tan pi by 2 minus alpha is cotangent alpha. So cotangent pi theta by 2. Follow? Or this can be written as limit theta tends to 0. Theta by tan pi theta by 2. Well, you know, limit tan a theta by theta, theta tends to 0 is a. Limit sin x by x as x tends to 0 is a. Limit tan x by x as x tends to 0 equal to a. So limit tan pi theta by 2 by theta is pi by 2. So the reciprocal of that. Therefore, this limit is 2 by pi, which is the second option. Next. This is also a joint entrance question 96 paper. Limit x tends to 0, 1 plus 5x square by 1 plus 3x square whole power 1 by x square. We use this result, limit 1 plus ax whole power 1 by x as x tends to 0 is equal to e power a. A very standard result, because this comes from limit 1 plus x whole power 1 by x as x tends to 0 equal to e. So from that you can simply reduce that limit of 1 plus ax whole power 1 by x as x tends to 0 is e power a. Now here the numerator, limit 1 plus 5x square whole power 1 by x square. When x tends to 0, x square also tends to 0. So therefore, if you write even ax square and 1 by ax square and also here also, the result is the same. And therefore, the numerator limit is e power 5 and the denominator limit is e power 3, which is equal to e square. 27. Well, this is in the 0 by 0 form. Clearly, the four options indicate that the limit very much exists. లిమిట్ ఖచ్చితంగా ఎగ్జిస్ట్ అవుతోంది, ఎందుకంటే 4 ఆప్షన్స్లో ఏదో ఒకటి కరెక్ట్ ఆన్సర్ కాబట్టి లిమిట్ ఎగ్జిస్ట్ అయిందని ఇచ్చినట్టే. ఆ లిమిట్ ఎంతని అడిగారు. సో వీ కెన్ సేఫ్లీ అప్లై ది లోపిటాల్స్ ఫార్ములా బికాజ్ ఇన్ 0 by 0 ఫార్మ్ అండ్ ది లిమిట్ ఎగ్జిస్ట్. సో దిస్ ఈజ్ 2 by 1 plus 2h, that is the derivative of natural logarithm 1 plus 2h minus 2 by 1 plus h by h square, derivative of h square is 2h. Well, 2 can be cancelled throughout numerator and denominator, and this is 1 plus h minus 1 plus 2h by 2h into రాయకపోయినా పర్వాలేదు 1 plus h into 1 plus 2h, because the limit of this factor is this is 1 as h tends to 0. So, this can be left out. Now, this is 1 will cancel out, h minus 2h is minus h by 2h, that is equal to minus 1 by 2. Oh, 2 is already cancelled, because here 2 is cancelled from numerator and denominator. So, minus h by h, which is equal to minus 1, which is the third option. Okay. This strange question here, the integer n for which limit extends to 0 cos x minus 1 into cos x minus e power x by x power n is a finite non-zero number. The limit very much exists, the limit is always different from 0. What is the integer value of n for which this given limit is a non-zero number? Finite, it is finite, it is a non-zero number. Okay? It is a real number not equal to 0. Now, we make use of well, n equal to 1, the limit is one minus cos x by x into cos x minus e power x. That is a given limit for the value of n equal to 1, but the given this limit 1 minus cos x by x has a limit 0, because the same as sin x by 1, limit sin x as x tends to 0 is 0, and this also has a limit 0, because cos x limit is 1 and e power x limit is 1. So, cos x minus e power x also has a limit 0. So, this is equal to 0. So, n equal to 1 is not the desired value, because the limit is 0. He says that limit is a finite non-zero number. N equal to 2. I will slightly change this 1 minus cos x by x square into cos x minus e power x. Well, once you write like this, you can easily see that the first factor has a limit 1 by 2 and the second factor has a limit 0. So, this is 0. So, n equal to 2 is also not the required number. N equal to 3, required value of n. Let us see here, limit extends to 0, 1 minus cos x by x square into cos x minus e power x by x. This can be written as cos x minus 1 plus 1 minus e power x by x. I think I can write like this, add 1 and subtract 1. This is 1 by 2, 1 minus cos x by, oh, this is n equal to 3, yeah. 1 minus cos x by x has a limit 0. ఇక్కడ చూసాం మనం ఫస్ట్ కేసులో 1 minus cos x by x has a limit 0. So, cos x minus 1 by x also has a limit 0. E power x minus 1 by x has a limit 1. So, 1 minus e power x by x has a limit minus 1, which is equal to minus half, not equal to 0. So, n equal to 3 is the desired value. Okay. Next, 29. This is a AEEE question. Now, mains, formerly AEEE up to 2012, the name was AEEE. From 2013 onwards, AEEE is changed to mains now, present mains, JEE mains. Let alpha and beta be the distinct roots of the quadratic equation ax square plus bx plus c equal to 0. Then what is the limit? 1 minus cosine ratio of ax square plus bx plus c by x minus alpha whole square as x tends to alpha. Well, I will write this as 1 minus cos ax square plus bx plus c by ax square plus bx plus c whole square into ax square plus bx plus c by x minus alpha whole square. I think I am correct. I have multiplied the given quotient which is the whose limit is required by ax square plus bx plus c whole square and divided by also ax square plus bx plus c whole square. The advantage here is when x tends to alpha, ax square plus bx plus c tends to 0. Why? Because alpha is the root of the quadratic equation. You have a alpha square plus b alpha plus c equal to 0. All polynomial functions are continuous throughout the real line. So, as x tends to alpha, the limit of ax square plus bx plus c is same as its value, a alpha square plus b alpha plus c, which is 0. And therefore, this is in the form 1 minus cos theta by theta square as theta tends to 0, which is 1 by 2. And ax square plus bx plus c by x minus alpha. When alpha and beta are the roots of ax square plus bx plus c equal to 0, x minus alpha and x minus beta are the factors of ax square plus bx plus c using the remainder theorem. And therefore, the factorization of ax square plus bx plus c is given by a times x minus alpha into x minus beta. So, the numerator is a times x minus alpha into x minus beta by x minus alpha, which is a times x minus beta whole square. As x tends to alpha, alpha minus beta whole square. So, that is a times alpha minus beta whole square by 2 or a square by 2 into alpha minus beta whole square, which is 2, 30. This is 29. This is the EAPCET question. Limit extends to pi by 2. 1 minus tan x by 2 by 1 plus tan x by 2. What is 1 minus tan x by 2 by 1 plus tan x by 2? Tan, I can write it as tan pi by 4 minus x by 2. By, and the denominator you have pi minus 2x whole cubed. I will take out one pi minus 2x from this as a factor. The remaining factor is pi minus 2x whole square. Pi minus 2x can be written as 4 times pi by 4 minus x by 2. Follow? Into 1 minus sin x. 1 minus sin x can be written as pi by 2 minus x. By pi minus 2x whole square is there, because already we have taken out one pi minus 2x, which is expressed as 4 times pi by 4 minus x by 2. So, pi minus 2x whole square can be written as 4 times pi by 2 minus x whole square, because pi minus 2x is 2 times pi by 2 minus x. Whole square means this. Now, this limit of tan theta by theta, theta tends to 0 when x tends to pi by 2, theta pi by 4 minus x by 2 also tends to 0, which is 1. So, this is 1 by 4 into, this is 1 minus cos theta by theta square, whether pi by 4 minus x by 2 or pi by 2 minus x, both tend to 0 as x tends to pi by 2. So, 1 minus cos theta by theta square, whose limit is half. So, 1 by 8, which is therefore equal to 1 by 32, which is the third option. Okay. Next, 33. 2015 JEE mains online. There are 2 papers online and 1 paper offline, pen and paper model, and the remaining 2 papers are online, just like the present EAPCET, which is only online. Limit e power x square minus cos x by sin squared x as x tends to 0. Don't jump to the straight away jump to the usual practice of applying the L'Hopital's formula once you find the given quotient in the form 0 by 0 indeterminate form. So, that sometimes plays havoc. You may be wasting time. Here you see the idea here is e power x square minus 1 plus 1 minus cos x by sin square x, x square into sin x by x whole square. Okay? Sin square x is written as x square into sin x by x whole square as x tends to 0. And because the limit of sin x by x as x tends to 0 is 1, this is 1. So, it has no impact on the limit, because multiplying any number by 1 gives the same number. And limit e power x square minus 1 by x square is 1, plus limit 1 minus cos x by x square is 1 by 2, which is equal to 3 by 2. That is the final answer, which is the second option. 34. P equal to limit 1 plus the tan square root x whole power 1 by 2x as x tends to 0 from right. 0 plus anna, 0 from right anna, positive values kunda x 0 ni approach avutundanna okate. Then what is the value of log p? 2016 JEE mains. You see, this limit is in the form 1 to the power of infinity. 1 plus tan square root x tends to 1 as x tends to 0. From the right, of course, because of the presence of root x, x cannot take negative values. 1 by 2x tends to plus infinity. So, this in the indeterminate form 1 to the power of infinity. And therefore, we can apply that formula for the limit of fx whole power gx as x tends to a, when both base fx tends to 1 and exponent gx tends to plus infinity as x tends to a. Okay? So, this is e to the p equal to e to the power of 1 by 2x into 1 plus tan square root x minus 1, which is tan square root x. Okay? Or this is e power 1 by 2 into tan root x by root x whole square. Because the tan root x by root x whole square is tan square root x by x, that is x is here, and this limit of this is 1. So, this is e power half. So, the given limit is p equal to e power half. So, what is the log p to the base e, or ln p is equal to 1 by 2. So, 1 by 2 is the answer, which is the third option. Generally chala easy ga untayi, koddiga practice cheste, pedda time taking kaadu, peddaga working kuda avasaram ledu. Okay, next 35. Same paper, online paper, 35. Limit 1 minus cos 2x whole square by 2x tan x minus x tan 2x. Koddiga slight variation తోటి ఇటువంటి ప్రాబ్లం మనం చేసాం మనం అంతకుముందు. అక్కడ ఏం చేసాం అదే చేద్దాం. ఇవాళ చేసి ఈ క్లాస్లో ఎపిసోడ్లోనే చేసాం మనం. డినామినేటర్లో 2x tan x minus x tan 2x. Replace tan 2x by 2 tan x by 1 minus tan squared x. So, this limit extends to 0. 1 minus cos 2x whole square by 2x tan x into, I am taking out 2x tan x common, 1 minus tan x by 2x tan x is taken out common, 2 tan x by, so 2x tan 1 by 1 minus tan squared x. The simplification చాలా జాగ్రత్తగా ఉండాలి. మనం ఎక్కువ స్టెప్స్ రాయడానికి లేదు, స్పేస్ ఉండదు, టైం ఉండదు. ఈ క్విక్నెస్ డెవలప్ చేయాలి. 1 minus 1 by 1 minus tan squared x is minus tan squared x. So, minus tan squared, this is a limit extends to 0 plus 0, 1 minus cos 2x whole square. This is minus tan squared x. So, minus 2x tan cubed x into 1 minus tan squared x. నేను రాస్తున్న అన్ని స్టెప్లో కూడా. Now, as x tends to 0, 1 minus tan squared x has a limit 1. So, you can ignore that factor. Now, divide numerator and denominator by x power 4 because of the presence of tan cubed x and x is here. So, minus 1 by 2. 1 minus cos 2x by x square whole square by tan x by x whole square L cube as x tends to 0. See, this 1 minus cos 2x by x square has a limit 1 by as a limit 2, because 1 minus cos 2x is a 2 sin squared x by x square. So, that is the 2 square 4. So, minus half into 4 by 1. Of course, this is a minus 2, which is the first option. Okay. 36. if limit extends to infinity, ఇక్కడ ఇంతవరకు extends to a అంటే limit of fx as extends to a అవి డిస్కస్ చేసాం. ఇక్కడ x approaches infinity, extends to infinity means x always remains positive and take numerically large values. For all such large, sufficiently large positive values of x, what is the behavior of the function fx? That is what you mean by writing limit fx as extends to infinity. Now, here also you can use the same thing, because the base tends to 1 as x tends to infinity, a by x tends to 0 and b by x square also tends to 0. Okay? And the exponent 2x tends to plus infinity. So, the base tends to 1 and the base tends to 1 and the exponent tends to plus infinity. Whether the limit is at x equal to a or as x tends to plus infinity, the formula is the same, and therefore, this is e to the power of 2x times limit x tends to infinity 2x times fx minus 1 a by x plus b by x square. Well, 2x into a by x is 2a, 2x into b by x square 2b by x. 2b by x tends to 0 as x tends to infinity. This being a constant, this is e power 2a. This is given to be e square for the value of a equal to 1. So, there is no mention of b. For all values of b, the second term here 2bx by x square, which is 2b by x tends to 0. So, it does not matter whether b taken a real value, regardless how you choose the value of b, the final outcome is the given limit is e power 2a, which is equal to e square only for the value of a equal to 1. So, you can choose b arbitrarily, but a must be equal to 1. So, the answer is the second option. Okay. 37. If a, b, c, d are positive real numbers, then limit n tends to infinity 1 plus 1 by a plus bn whole power c plus dn. What is this limit? Well, this is once again, this can be written as 1 plus 1 by a plus bn tends to 1, because a plus bn tends to plus infinity, or positive, because a, b, c, d are positive real numbers, a plus bn tends to plus infinity as n tends to plus infinity. So, 1 by a plus bn tends to 0 and c plus dn tends to plus infinity. So, base tends to 1 and exponent tends to plus infinity. So, same as the previous example 35 or 36, you can also write this limit as e to the power of limit n tends to infinity c plus dn into fx minus 1, 1 by a plus bn. Follow? So, that is of course what you get, or this is e to the power of limit n tends to infinity c plus dn by a plus bn. Well, divide each of the terms in the numerator c plus dn and denominator a plus bn by n. So, this will be c by n plus d by a by n plus b. This is the exponent. Well, you know, c by n tends to 0 and a by n tends to 0. Therefore, the limit is d by b. So, this is e to the power of d by b. That is the option 3 EAPCET question of 1998. Next, 38. Limit sine root of x plus 1 minus sine root x as x tends to plus infinity. Well, the limit very much exists, it seems, as per the question. The options are 2, minus 2, 0 and 1. Now, how do you try this? Sine root x plus 1 minus sine root x. Well, I write fx as minus sine root x. This is my fx. Okay. Then 0 less than or equal to mod fx, because mod fx is never negative. So, mod fx is always greater than or equal to 0. mod fx equal to, I apply the transformation for this. This is in the form sin A minus sin B. What is sin A minus sin B? 2 cos A plus B by 2 sin A minus B by 2. Therefore, using the transformation formula, you can write sin root x plus 1 minus sin root x as 2 cosine root x plus 1 plus root x by 2 cos A plus B by 2 sin root x plus 1 minus root x by 2. Okay. I once again repeat, this is in the form sin A minus sin B, which is 2 cos A plus B by 2 sin A minus B by 2. Well, cosine always has the maximum value 1. Therefore, this is less than or equal to twice mod sin. I write root x plus 1 minus root x as 1 by root x plus 1 plus root x. Follow? Root x plus 1 minus root x is same as 1 by root x plus 1 plus root x. When you multiply root x plus 1 minus root x by root x plus 1 plus root x, you get 1. Okay? And therefore, this is a sin 1 by 2 into root x plus 1 plus root x. As x tends to plus infinity, root x plus 1 plus root x and 2 times root x plus 1 plus root x, they both tend to plus infinity. So, the whole denominator tends to plus infinity. So, 1 by this tends to 0. Because sin is a continuous function on the real line, sin of this tends to sin 0, which is 0. So, the extreme function on the right, the mod fx is being squeezed by the constant function 0 on the left, and on the right it is squeezed by this function 2 times mod sin 1 by 2 times root x plus 1 plus root x, and this squeezing function on the right has the limit 0 as x tends to plus infinity. On the left also, the constant function being a constant function, its limit is 0. So, by sandwich theorem or squeezing principle, mod fx tends to 0. As x tends to plus infinity. Mod fx tends to 0 na, fx tends to 0 na utte, whether x tends to e or x tends to plus infinity or minus infinity. Therefore, fx tends to 0 as x tends to plus infinity. Follow? It's a very good question, but man normal ga intermediate lo manam chesi practice man intermediate lo chesi questions tho raadu idi. This is a direct application of the sandwich theorem. So, జాగ్రత్తగా దీని ట్రాన్స్ఫర్మేషన్ వేసి దాన్ని ఎస్టిమేట్ వేసి కొసైన్కి 1 మ్యాక్సిమం వాల్యూ అది ఎస్టిమేట్ వేసి ఆ తర్వాత దీనిలా మార్చుకున్నట్లయితే ఇదేమో ఈ రైట్ సైడ్ ఉన్న స్క్వేజింగ్ ఫంక్షన్ లిమిట్ 0 అని తెలిస్తే డెఫినెట్గా మనం శాండ్విచ్ థియరం అప్లై చేసి ఈ మోడ్ ఎఫెక్ట్స్ లిమిట్ కూడా 0 అని, అందుచేత ఎఫెక్ట్స్ లిమిట్ 0 అని తెలుస్తుంది అది ఎక్స్టెన్స్ టు ప్లస్ ఇన్ఫినిటీ. ఓకే, దేర్ఫోర్ ది ఆన్సర్ ఇస్ 0. వెరీ గుడ్ క్వశ్చన్. నెక్స్ట్ 39. లిమిట్ a power 1 by x plus b power 1 by x plus c power 1 by x by 3 whole power x, where a, b, c are real and non-zero. What is the limit of this function as x tends to plus infinity? It seems it was also given in the year 1998 EAPCET paper. Once again, as x tends to plus infinity, a, b, c are see, strictly speaking, a, b, c must be given to be real, positive, not real. Sometimes you cannot help it, because for real values of x, a power 1 by x is defined only when the base a is positive. Power function or exponential function, that a power x is defined only when a is positive. In fact, you know that when a lies between 0 and 1, a power x is a strictly monotonic decreasing function. For values of a greater than 1, a power x exponential function is strictly increasing. That is the monotonicity of the power function or a exponential function. Of course, when a equal to 1, that remains a constant function, neither increases strictly nor decreases strictly. So, the very definition of a power x clearly implies that the base a must be positive. ఇక లైట్ ఆగిపోయిందండి, పర్లేదు కదా, వచ్చింది. ఓకే. And therefore, here in the question they should have given that a, b, c are positive అయితే సరిపోయింది. రియల్ అండ్ నాన్ జీరో ఇచ్చారు. రియల్ అండ్ నాన్ జీరో షుడ్ బి రిప్లేస్డ్ బై పాజిటివ్ ఇస్తే క్వశ్చన్ కరెక్ట్గా ఉండేది. సో అస్యూమ్ లైక్ దట్. దెన్ a power 1 by x tends to 1. Because 1 by x tends to 0 as x tends to plus infinity, a power 1 by x tends to 1. b power 1 by x also tends to 1 for the same reason. c power 1 by x tends to 1. So numerator has the limit 3 by 3, so the base has the limit 1 and the exponent tends to plus infinity. So this is again in the form 1 to the power of infinity, indeterminate form, and the limit very much exists, and therefore this limit is same as e to the power of limit x tends to infinity x times a power 1 by x plus b power 1 by x plus c power 1 by x by 3 minus 1. Okay. fx whole power gx limit as x tends to infinity, 1 to the power of infinity form lo ఉన్నప్పుడు that is same as e to the power of limit x tends to infinity gx times fx minus 1. ఈ LCM తీద్దాం. అది తీస్తే ఏమవుతుందంటే I can write it as 3 whole by a power 1 by x plus b power 1 by x plus c power 1 by x minus 3 by 3, or this can be written as x tends to infinity. I will take out 1/3 outside this parenthesis, and this can be written as a power 1 by x minus 1 by x plus b power 1 by x minus 1 by x plus c power 1 by x minus 1 by x. I hope I am clear. Follow this. A power 1 by x plus b power 1 by x plus c power 1 by x minus 3 whole by 3. I split this 3 as the 1 minus 1 minus 1 minus 1. So a power 1 by x minus 1 by x, not x. This is x is there in the numerator. So this is 1 by x, x power minus 1. So a power 1 by x minus 1 by 1 by x, not x, because x is there in the numerator. X is same as 1 by 1 by x. b power 1 by x minus 1 by 1 by x, c power 1 by x minus 1 by 1 by x. 1 by x, if you write it as y, 1 by x tends to 0, of course through positive values as x tends to plus infinity. So each of the terms has a limit. The first one has the limit ln a, the second one has the limit ln b, the third one has the limit ln c. So this is ln a plus ln b plus ln c, which is ln abc. 1/3 ln abc. Or this is ABC whole power 1 by 3, because 1/3 ln ABC is ln ABC power 1 by 3, e to the power of ln ABC whole power 1 by 3 is ABC whole power 1 by 3, which is the option 2. 40. FR2 are a positive increasing function with the limit x tends to infinity f of 3x by f of x equal to 1. Then what is the limit of f of 2x by f of x as x tends to infinity? F is a positive increasing function. Well, it doesn't say whether it is increasing strictly or not, but simply increasing, monotonically increasing, may be strictly increasing or may not be strictly increasing. And also you are given the limit of f of 3x by fx as x tends to plus infinity equal to 1. You are asked to find the limit of f of 2x by f of x as x tends to infinity. What is the value? Well, because f is an increasing function and f is positive, fx is positive means 0 less than fx. Increasing, that means 2x is always greater than x. And therefore, the less than or equal to f of 2x, less than or equal to f. Equal to ఎందుకు పెడుతున్నారంటే స్ట్రిక్ట్లీ ఇంక్రీజింగ్ అయితే స్ట్రిక్ట్ ఇన్ఈక్వాలిటీ వస్తుంది, అదర్వైజ్ ఈక్వల్ కూడా అవ్వచ్చు. కాన్స్టెంట్ ఫంక్షన్ కూడా ఇంక్రీజింగ్ అని చెప్పుకోవచ్చు, డిక్రీజింగ్ అని చెప్పుకోవచ్చు. సో fx is positive, but this is the relation between f of x and f of 2x and f of 3x. Divide throughout by this positive quantity f of x, 1 less than or equal to f of 2x by f of x less than or equal to f of 3x by f of x. Okay. So, this is what you can write using the hypothesis. Simply that f is a FR2R is a positive increasing function. దాని నుంచి మనం conclude చేయగలిగింది ఇది. Okay. Now, given that this f of 2x by f of x is sandwiched by 1 on the left and f of 3x by f of x on the right, and whereas 1 is a constant function, the limit of the function on the right, squeezing function on the right, f of 3x by f of x is given to be 1. So, it is a direct application of the sandwich theorem. Because this tends to 1 as x tends to infinity, this is already 1. The middle function f of 2x by f of x also tends to 1. Therefore, f of 2x by f of x tends to 1 as x tends to plus infinity. I hope I am clear. So, this is the question number 40. So, look at the question number 41. If a limit extends to infinity, 1 plus a by x minus 4 by x square whole power 2x equal to e cubed, then what is the value of a? Last year, before last year, 2016 mains online paper. Well, once again, 1 plus a by x minus 4 by x square has the limit 1 as x tends to plus infinity, and the exponent 2x also tends to plus infinity as x tends to plus infinity. So, they are clearly in the form 1 to the power of infinity, and therefore, this limit is same as e to the power of limit x tends to infinity. Well, I am doing 41st question. There are two questions on the screen. So, one need not be confused about the solution I am offering now. It is the solution for question number 41. This is 2x times f x minus 1, a by x minus 4 by x square. I think we have done a similar question previously. Or this is e to the power of 2x into a by x, but the constant 2a, minus 2x minus 4 by x square equal to 8 by x, minus 8 by x as the limit 0 as x tends to plus infinity. So, e power 2a is given to be e cubed. So, this implies a equal to 3 by 2. So, very simple questions. Once you practice, I do not think that you need not need facing any new questions and also complicated questions. Absolutely, there is no need to waste time in the examination paper once your practice is on the sound lines, on the correct lines. So, question number 42, the JEE, now advanced question. Limit x tends to 0, tan pi by 4 plus x whole power 1 by x. Once again, tan pi by 4 plus x tends to 1 as x tends to 0, because pi by 4 plus x as the limit pi by 4, tan pi by 4 is 1, and therefore, tan pi by 4 plus x as the limit 1. 1 by x, of course, when x tends to 0 through positive values tends to plus infinity. When x tends to 0 through negative values, 1 by x tends to minus infinity, and the whole limit is 0. And therefore, that 0 option is also there. Well, they should have given 0 plus. Well, when x tends to 0 through negative values, 1 by x tends to minus infinity, and this is 1 to the power of minus infinity, 1 to the power of minus infinity, or maybe there is also, you can take it as a indeterminate form. So, no matter whether x tends to 0 through positive values or negative values, and this will be e to the power of 1 by x into limit, of course, as x tends to pi by 4, as x tends to 0, 1 by x into tan pi by 4 plus x minus 1, f x minus 1. This is f x minus 1. What is tan pi by 4 plus x minus 1? E to the power of limit x tends to 0, 1 by x, 1 plus tan x by tan a plus b, it is at the form tan a plus b, tan pi by 4 plus x, tan pi by 4 plus tan x, which is 1 plus tan x, by 1 minus tan pi by 4 into tan x, which is 1 minus tan x, minus 1. What is 1 plus tan x by 1 minus tan x minus 1? 1 plus tan x minus 1 minus tan x is 2 tan x. Therefore, this is e to the power of, limit x tends to 0, 2 tan x by x into 1 by 1 minus tan x. You can also ignore 1 by 1 minus tan x because that has the limit 1. Okay. 2 tan x by x has the limit 1, 1 by 1 minus tan x has the limit 1. So, therefore, this limit is e square, which is the last option. Next, question number 44. If limit extends to infinity, x square plus x plus 1 by x plus 1 minus ax minus b equal to 4, then what are the values of a and b? It's an advanced paper now. 2012 JEE means is meant for the students seeking admission into IITs, not the mains. Simple JEE, then it was advanced only. After the introduction of mains, they say now JEE mains in the place of IEEE and JEE advanced in the place of earlier JEE. Okay. What are the values of a and b? I think you need a simple result. Suppose limit fx by gx as x tends to a equal to L not equal to 0 and gx tends to 0 as x tends to a. Then fx tends to 0 as x tends to a. Okay. A simple result because fx is fx by gx into gx, fx by gx has the limit L, gx has the limit 0. So, product function has the limit L into 0, that is 0. So, when the quotient function has the limit non-zero limit and of course, when L equal to 0 also this happens, no matter whether L not equal to 0, L equal to 0. So, when the denominator function has the limit 0 as x tends to a, the numerator also must have a limit 0 as x tends to a. So, these 44 and 45, both the questions are based on this simple result. Okay. Now, let us see 44. Is limit x tends to infinity, LCM teddam. Let us take LCM, x square plus x plus 1 minus of ax plus b into x plus 1 by x plus 1. ఇటువంటి క్వశ్చన్స్లో మామూలుగా x బదులు 1 by y పెడతాం. Then y tends to 0 through positive values. So, this will be limit y tends to 0 through positive values. 1 plus y square, of course, by y square. To be more specific, అది కూడా రాస్తాను, minus a plus by into 1 plus y by y square by 1 plus y by y. Okay. Now, 1 y square, 1 y can be cancelled and this is the limit x tends to y tends to 0 plus 1 plus y square minus of a plus by into 1 plus y by y into 1 plus y. Because this y square comes to denominator, y square by y is y. Now, look at here, this has a limit 4. The whole thing is the limit 4, whereas the denominator tends to 0, y into 1 plus y tends to 0. So, by the earlier result we have stated just here, numerator also must have a limit 0. So, first term has the limit 1, second term has the limit a, 1 minus a 0. This implies a equal to 1. That is how you can get the value of a. Okay. And what about b? Once a is 1, I can replace a by 1 and 1 can be cancelled. This implies limit. You can take out y common, y can be cancelled, 1 plus y minus b into 1 plus y by 1 plus y, which is equal to 1 minus b. Now, this is given to be 4. Let us see, y tends to 0. 1 plus y square minus of a plus by into 1 plus y by this. When a equal to 1, 1 and 1 can be cancelled. Of course, this by square term is also there. Yeah. By into 1 plus y. So, b into 1 plus y. So, 1 and 1 is cancelled. Okay, this 1 plus will not be there. Okay, y minus b into 1 plus y plus by square, b plus 1, 1 plus b into y square. Okay. Now, as y tends to 0, this is 0, this is 0, this is minus b, no 1. So, minus b equal to 4. That means b equal to minus 4. So, a equal to 1 and b equal to minus 4, which is the second option. I think you can try the next question also, that the values of alpha and beta, so that limit extends to infinity, x squared plus 1 by x plus 1 minus alpha x minus 2 beta is equal to 3 by 2 are given by these 4 options. I think you can try this question just on the same models as we tried the 44th question. Okay. The answer is the fourth option, that is alpha equal to 1 and beta equal to minus 4. 46. Limit extends to infinity, x power minus infinity, not infinity, minus infinity, x power 4 sin 1 by x plus x square by 1 plus mod x whole cube. Here x is negative. So, mod x is minus x. So, this is x power 4 sin 1 by x plus x square by 1 minus x cubed. Divide by x cubed, x sin 1 by x plus 1 by x by 1 by x cube minus 1. This has a limit 1 as extends to minus infinity. This is minus 1. So, therefore, this is equal to minus 1, which is the second option. Okay. So, we conclude these limits and we go to the continuity in the next episode. Thank you.